Hello students. So this is your third lecture. So we are going to see about strain energy stored in the body when the load is suddenly applied. So we are going to see when load is suddenly applied, what strain energy is going to stored in the body. So in the last lecture I have taught you the strain energy stored in the body when the load is gradually applied. So what is strain energy? U is equal to sigma square by 2E into AL, right? So in this unit, in this lecture, we are going to see this thing. So since the load is applied suddenly, therefore the load is constant throughout the process of deformation of the. So at the gradually applied load, it is from 0 to a particular maximum load. So we have took average load, right? So P by 2 will be the average load. But since here it is suddenly applied, your load will be as it is P only. Okay, there will be no average load. So your work done is equal to force into distance, that is nothing but loaded deflection. So load is nothing but P. There will be no change in load because suddenly the total load is applied. It's not from 0 to P and all. So P into dou L. You know the strain energy stored, that is equal to U is equal to sigma square by 2 into AL. That is your strain energy that you have derived from the strain energy due to gradual apply. So U is equal to sigma square by 2E into AL. Since the strain energy stored in the equation is equal to the work done, therefore sigma squared by 2E into AL is equal to P into dou L. So since the strain energy and your work done is equal, so we can write like this, right? So U square strain energy and work done is equal U square, sigma squared by 2E into AL, that is strain energy. U and work done is equal. So here what is work done? P into dou L is work done. So this P into D or dou L we can write like this, right? So we can write like dou L is nothing but what? Strain is equal to dou L by L. So you can write like dou L is equal to strain into L. We can write like this, right? What is strain actually? Strain is nothing but what? Sigma by E. CE into L. You can write like that. Strain is nothing but what? So modulus of velocity sigma by strain. Strain is equal to sigma by. So you can write like sigma by E into L in case of dou L. So you can write like here P into sigma by E into L. You can write like this, right? So substitute here in this equation. So sigma by 2E into AL is equal to P into sigma by E into L. Okay, you can write like this. So that's the thing here. So sigma by 2E into AL is equal to P by E into L. So now you need sigma stress, that what stress applied. So this stress, one stress and one stress is cancelled. E and E will be cancelled. L and L will be cancelled. So your stress is equal to, one stress will be there because sigma square, stress is equal to 2 into P by this A will come this side, P by A. Okay, so that is the thing with stress or strain energy. So stress is equal to 2 into P by A. It means that in this case it is twice the stress induced when the same load is applied gradually. So this is your suddenly applied load strain energy. So next we will move on to the problem. The axial pull of 20 kilonewton. So pull load is given, P is equal to 20 kilonewton, 2 into 20 into 3 Newton. Is suddenly applied. They have given suddenly applied. Suddenly applied means you have to go for suddenly applied load derivation. Suddenly applied on a steel rod of 2.5 meter long. So length is given. Length is 2.5 meter long. So converted to 2.5 into 10.3 millimeter. Then 1000 mm square is cross section. So area is given. Not in the previous problem they have given breadth and thickness. Here this area is given, breadth and thickness same. Because to calculate the strain energy which can be established absorbed in the rod, take Young's modulus E is equal to 200 into 10 power 3 GPa. It is given as GPa. So you can write it as 200 into 10 power 3 MPa. You can write like this. Okay. So you know your strain energy absorbed in the rod is U is equal to sigma squared by 2E into V. You know V is nothing but what? Length into area. Length is there, area is there. So what is length? 2.5 into 10 power 3 meter. Substitute and area 1000. You will get 2.5 into 10 power 6 millimeter cube. Okay. Then what is your stress actually? You have E. E is given in your question itself. E is 210 power 3 Newton per mm square. And V, how you will calculate? V is nothing but area into L. Area is 1000. Length is here. You have calculated. Next you have to find sigma. Sigma is nothing but what? According to your strain suddenly uploaded, sigma is equal to 2 into P by A is your sigma. So write formula, sigma is equal to 2 into P by A. That is equal to 2 into your load is given 20 into 10 power 3 divided by area is nothing but what? 1000. Substitute 440 Newton per mm square, you will get sigma. So now substitute sigma, E value, V value in this equation. So 440 square divided 440 square, okay, 440 square divided by 2 into E, 200 into 10 power 3 into your volume is 2.5 into 10 power 6. If you substitute and solve this equation, you will get 10 into 10 power 3 Newton millimeter, or you can write it as 10 kilonewton millimeter. Okay, so this is the strain energy stored in the body. So this is the strain energy stored in the body due to the suddenly applied load. So next we will move on to strain energy stored in a body when the load is applied with impact load. Okay, when a body is applied with impact load. Now consider a bar subject to load applied with impact. So consider a bar. See, this is a diagram. You can see this is the surface. Here a bar is there. A load is at a distance of h. So this load is led to fall from a height to impact this collar. Okay, so then we will see what type of how much load we are going to get due to the impact load. What is strain energy due to the impact load? So let P is equal to load applied with impact. Area A is equal to cross section area of the bar. E is equal to modulus of elasticity. L is equal to length of bar. Dou L is deformation of the bar. Sigma stress. H is equal to height of the load from the collar. Okay, so that is how you will find your strain energy that is stored in the body due to the impact load. So you know what is work done? Work done is equal to load into distance, load into deformation. So distance mode. So your load is P. Distance is nothing but the load is at a distance of height and the deformation is dou L. So H plus dou L, load into H plus dou L. So because since it is na different particular height, okay, H plus dou L. You know your strain energy U is equal to sigma square by 2E into AL. Since energy stored is equal to the work done, therefore, so equate these two equations, P into H plus dou L and U is equal to sigma square 2E by 2E into AL. If you equate these two equations, you will get, you know already, right? What is dou L? Dou L is equal to strain into length. Strain is nothing but, you can write this as sigma by E into L. That is how we have written. They have written here P into H plus sigma E into L. They have written here. So equate these two equations. If you equate these two equations, you can substitute inside PH plus P sigma L by E. You can write like this, right? Sigma square by 2E into AL is equal to PH plus P sigma L by E. You can write like this. Then you can you need to find the stress, that is sigma. In suddenly applied load, you have find stress like the sigma is equal to 2 into P by A. Now you have to find the stress from this equation. For that, what you are doing is sigma squared AL by 2E. Take all the terms to that side and make it as the right hand side 0, and using quadratic equation you can find the stress. So I will teach you. So see, sigma squared commonly they have taken took outside AL by 2E, then minus again what there one sigma is that take that outside PL by E minus this PH minus PH. So if you take all to the left hand side and making it as 0 at the right hand side, so now you have to eliminate the what is the common term in everything. There is L by E is common term, okay, and area is also common, so constant. Area L and E is constant everywhere, so you can eliminate. So multiplying both side E by L, if you multiply both side E by L means E by AL means you can eliminate all these things. So if you multiply here E by AL, so E by AL, so this AL will cancel, L will cancel and EE will cancel, okay, and then sigma into PL by AE, L and E will cancel here. So you can write like sigma squared by 2 minus sigma into P by A, because A is model, minus PEH by AL is equal to 0. So if you do this, you can get this equation. So this is a quadratic equation. You know what is quadratic is. So this you can take it as A, B, C. What is quadratic equation? That is nothing but B plus or minus root of B square plus 4AE. AC. You know this quadratic equation mathematics, right? B plus or minus root of B square plus 4AC. So what is B here? P by A. So sigma is equal to, sigma take it as common term, sigma is equal to P by A plus or minus B plus or B, P by A plus or minus root of B squared, P by A squared plus 4 into A. A is nothing but if you take the sigma outside, what is A? There will be 1 by 2 only. So 4 into 1 by 2, and here C is nothing but what? PEH by AL, because there is no sigma. So you can take PEH by AL. So if you simplify this equation, P by A, if you take common PC, here also P by A is there, P by A is there, P by A take common, if you take P by A common, you will get 1 plus or minus root of 1 square is 1 plus, if you simplify this equation, you will get 2 2's are 4, so 2 A E H, because what you will do is you will multiply by A by P. Yes, you will multiply by A by P. Both the sides you will multiply by A by P. Here also A by P. So this A will cancel, this PP will gets cancelled, like that. Here also A by P you will multiply. So if you multiply means it will cancel and it will become 2AEH by PL. Become ulta, okay. So where dou is very small as compared to H, then work done is equal to P into H. So because it is in a, since it is in a particular height, see you can see here P into H plus dou L. Since dou L is very smaller because of impact load, it can be eliminated. So your work done will become P into H. P into H. So sigma square 2E by AL. Sigma square 2E into AL is equal to P into H. Sigma squared is equal to 2E. See, you can take that 2E to that side and AL to the downside. 2E PH by AL. Sigma is equal to root of 2E PH by AL. You can write like this. Okay. So 2E PH by AL, since it is very small. So this is your sigma for impact load, and sigma for suddenly applied load is 2 into P by A. Sigma for, so see, you know work done is equal to PH. Sigma square by 2E into AL is your strain energy stored. Sigma square by 2E into AL is equal to PH. So take all these things that side, 2E PH by AL. Sigma is equal to root of 2E PH by AL. So this is how you will derive your. So now we will see the problem based on your impact load. A 2 meter long, so given length is equal to 2 meter, 2 into 10 power 3 millimeter of 1500 mm square. So cross sectional area. So the area is given, area is equal to 1500 mm square. Vertically and has a collar securely fixed at its lower end. Find the stress induced in the bar when a weight of 2 kilonewton falls from a height H is given, load P is given, 2 kilonewton, P is given, 2 kilonewton means 2000 Newton, and height H is equal to 100 mm, E is also given 120 GPa, that is nothing but 120 into 10 power 3. So also find the strain energy stored in the body. So they are asked you to find the stress induced in the bar due to the, so if they have mentioned height in the body in a question, means the question is under impact load. Okay, so what is stress induced for due to impact load? That is nothing but sigma is equal to root of 2E PH by AL. So that is equal to 2 into E is 120 into 10 power 3 into load P is equal to 2000 into 2000 Newton into H, height is given what 100 mm divided by area is also given 1500 mm square into length is 2 into 10 power 3. So if you simplify this, solve this, you will get 126.5 Newton per mm square. So now you have calculated sigma. Next, what is strain energy formula? U is equal to sigma squared by 2E into V. That is your strain energy formula. So that is, so you have sigma. E is also there. Volume is nothing but what? Area into length. So area is given, length is given. Area is nothing but 1500 into length 2 into 10 power 3. If you multiply these things, you will get volume. So now substitute in this formula to get strain energy. So 126.5 sigma squared is the phi squared. Sigma 126.5 square divided by 2 into your Young's modulus E. modulus height 120 into 10 power 3 is given in the question, and volume T into 10 power 6. If you derive this, you will get your uniform your strain energy 200 into 10 power 3 Newton millimeter. Okay students, so your unit number 7 is finished from this, and I have completed your syllabus. Okay, I have completed your syllabus. So if you have any doubts, okay, you are free to ask me in my personal chat, not in the group. You can ask me in personal chats, so I will explain you again through YouTube videos. Okay students, see you, bye.